Hey everyone, today we're going to be doing some problems from Larson Edwards Calculus textbook, section 2.2, Basic Differentiation Rules and Rates of Change. It's important to keep in mind that we're going to be taking these questions out of the 11th edition of the textbook. So if you have the 12th edition version, which was released in 2023, or an earlier version of the book, then some of the coefficients on the functions that we do or the order of the problems might not be exactly the same as your textbook, but it should come pretty close. So in section 2.2 of this book, there were 5 key takeaways: the constant rule, the power rule, the constant multiple rule, the sum and difference rules, and derivatives of sine and cosine functions. Just to quickly recap these, the constant rule tells you that the derivative of any constant, so that's to say a term not involving x, just a number, is 0. In general, it says that d dx of c is equal to 0. Now, what does that look like? For example, d dx of 1 is equal to 0. d dx of, let's say, 7 is equal to 0. d dx of 1,000,000 is equal to 0. Then we have the power rule, which is super important because very often when you'll be doing these types of problems, there will be some polynomial terms in the function, and that's where this comes in. So how do you do this in practice? It tells you that the derivative with respect to x of x to the n is equal to nx to the n minus 1. So what you do is you see x to the n and you bring the n out in front. So you write nx to whatever it was, n minus 1. Again, how does that look like? Let's say you have d dx of 4. Actually, let's do one without a coefficient. d dx of x to the 5th. So that would be equal to, you bring the n in front, 5x to the n minus 1, which is 5x to the 4th. The constant multiple rule is saying that if you have a differentiable function and c is a real number, then c times the function of f is also differentiable. So basically it tells you that d dx of some constant times a function is equal to the constant times the derivative of that function. How does that look like? Well, let's say y is equal to 5x squared. Here, 5 is your constant in front of x squared, and x squared is your f of x. So d dx of 5x squared is equal to the constant 5 times the derivative of f of x, which here is x squared, which is equal to 5 times, now this is going to use the power rule, so you bring the 2 in front, to x, because it's 2 minus 1 on the power, which is 1, so you don't write it, which is equal to 10x. The sum and difference rules are telling you that if you have a multi-term function of x, then the derivative of that function is equal to the sum of the individual derivatives or the differences of the derivatives that they're being subtracted. And then we have the derivatives of sine and cosine functions. And to be honest, at this stage, since these rules are so new to you, it would be best to just memorize these. If you need to use flashcards, then go ahead and use those. The derivative of sine of x is cosine of x. The derivative of cosine is minus sine of x. And just get familiar with those because they're going to come up quite a bit. Maybe just by using them a bunch, you'll commit them to memory over time. So now we're ready to jump into some practice problems. So for number 7, it says y is equal to 12. So we would write by the constant rule, which we saw was theorem 2.2. The derivative of 12, as you can see, there are no x terms in this equation. So the derivative of 12, which is a constant, is equal to 0. So now for number 8, y is equal to negative 9. Well, how do you think this one should go? We don't see any x terms in the equation, so same thing. By the constant rule, the derivative of negative 9 is equal to 0. Problem 9. Y is equal to x to the 7th power. So this time we do have a term involving x. So by the power rule, the derivative of some polynomial x to the n is equal to nx to the n minus 1, where n is the power of x. So derivative of y with respect to x is equal to the derivative of x to the 7th. And how did we say we do this? We said you take the exponent on x and you put it in front, so that becomes 7x to the n minus 1, so 7 minus 1 is equal to 7x to the 6th. That's our final answer. So number 10 says y is equal to x to the 12th power. So how do you do this? Well, you identify that there is a polynomial term of x in the equation. So we use the power rule again. The derivative of x to the n power is equal to nx to the n minus 1. So dy dx is equal to the derivative with respect to x of x to the 12th, which is equal to, bring the power in front, 12 that you see, x to the 12 minus 1, which is 11. There we go. Number 11. So this one looks a little funky. There is, as you can see, a power of x in the equation, but it doesn't look exactly like any of these templates, does it, in terms of the equation? Well, first of all, what we know for sure is that there is a power of x. It's in the denominator. So we will write by the power rule this time. But just really quickly, I want you all to remember that when you have a power of x in the denominator, or an exponent in the denominator of anything, then that's the same as taking something to the negative power. So, note, 1 over x to the 5th is equal to x to the negative 5th. That's how you make it 1 over the thing. So y equals 1 over x to the fifth is equal to x to the negative fifth. Now we write once again, there's our power of x term by the power rule. dy dx is equal to the derivative with respect to x of x to the negative 5 now. And now once again, as we've always seen, how do you take the derivative of a polynomial of x? You take the power and you put it in front. The power this time is negative 5 times x. So whatever you see is the power minus 1. In this case, negative 5 minus 1 becomes more negative. So we get negative 5x to the negative 6. And if we wanted to write it back the way the problem originally gave it to us, with the 1 over notation, remember that this is actually negative 5 times 1 over x to the 6th. So negative 5 goes in the numerator, negative 5 over x to the 6th, and that's our derivative. So here once again, we have the power of x in the denominator, but we also have a numerator that's not 1. But that's okay. So, like in the last problem, we said that when you have a power of x in the denominator, it's like saying x to the negative power of whatever the power of x is. So here, all you have to do is you multiply the coefficient by that negative power. Watch. This term is equal to 3 times x to the negative 7. Here it looks like we're going to use both the power rule and the so-called constant multiple rule. Remember that with the constant multiple rule, the derivative of a constant times a power of x is the same as the constant in front times the derivative of that power of x. So we write 3 times d dx of x to the negative 7th. And then this is the part where we apply the power rule. Again, how do we do that? You remember, you bring the negative 7 as the power in front times x to the negative 7 minus 1, which is negative 8. But you're multiplying all of this by 3. So that 3 times negative 7 times x to the negative 8 is negative 21x to the negative 8. And again, oops, it's taking the parentheses away. Again, if you want to write it in the way that the problem originally gave us, then once again you put negative 21 in the numerator and you put the power of x in the denominator, negative 21 over x to the 8th. Wow, this got really scrunched up. Let's see. F of x is equal to the ninth root of x. Well, this is another one of those where you have to remember some pre-calculus skills. Remember that the ninth root of x is actually like saying x to the 1/9 power. And that's what this really means. So, f of x is equal to x to the 1/9. Now that you spot the x term, the polynomial x term with the power, then we just use the power rule as always. The derivative of f of x with respect to x is equal to d dx of x to the 1/9. How do you do the power rule? You tell me. You should get it by now. You take the power in front, 1/9 x to the 1/9 minus 1. What's funny about this is 1/9 minus 1 is going to become negative. Equal to 1/9 x to the negative, how many? Negative 8/9 power. And negative 8/9, if you wanted, there's a way to write that in terms of square roots, but let's just leave it like this for now. So for the next one, this is g of x is equal to the quarter root of x. So how would you simplify this? Remember that when it was the ninth root, we put power as 1/9. So in this case, the quarter root of x is the same thing as x to the 1/4. So dg dx is equal to the derivative of x to the 1/4. You're a pro at this by now, so we know that we take the coefficient in front, x to the old power, which was a quarter. So we have 1/4 x to the 1/4 minus 1, which is negative 3/4. There's our derivative. Now we're getting into the sum and difference rules. We see that f of x is the sum of two terms. So by the sum rule, df dx is equal to the sum of the individual derivatives, d dx of x plus d dx of 11. So now this is going to use the constant rule for this one and the power rule for this one. How does that actually look like, by the way? The power rule for just x means x to the first power. So as you always have done, move the power in front of x. We get 1x to the 1 minus 1, which is 0, plus d dx of 11, which that uses the constant rule, as you know, which is 0. So what's 1 times x to the 0 power? Well, anything to the 0 power is 1. So it's 1 times 1 plus, as you remember from the constant rule, the derivative of 11 is 0. So the derivative of this expression is 1. Here we have g of x. Again, another sum rule. dg dx would be equal to the derivative of the individual terms. So, you know the power rule once again. This is a linear function of x, or a linear term. So, you take the coefficient and you put it in the front. And by the constant rule, we know that this is the same as writing 6 times, then you do the power rule, 6 times 1 x to the 1 minus 1 plus d dx of 3, which that by the constant rule you know is 0. So you can write this as 0 here already. So 6 times 1 times x to the 1 minus 1. 1 minus 1 is 0. And you know that anything to the 0 power is 1. So this is like saying 6 times 1 times 1, which is equal to 6, plus 0 is equal to 6. Here we have f of t, which uses both the sum and the difference rules. This one actually has a lot of different rules in it. So, df dt is equal to d dt of negative 3t squared plus d dt of 2t minus, because it's minus 4, minus d dt of 4. So what happens now? This first term takes advantage of the constant rule, so we know that we can write negative 3 times d dt of t squared plus, again, the constant rule, 2 times d dt of t minus d dt of 4, which this is going to be, I'm sorry. These take advantage of the constant multiple rule, and this is the constant rule because we know that the derivative of any constant is 0. So, negative 3 times the derivative of t squared, this is a power rule. Take the power in front, 2t to the 2 minus 1, which is 1, plus 2 times d dt of t, which is again kind of a power rule. Put the power in front, so it's 1 times t to the 1 minus 1 power, which is 0. So it's 2t to the 0th power, which is 1. So it is 2. Minus, the constant rule says that the derivative of any constant is 0. So we say minus 0. In this term, negative 3 times 2t, which is negative 6t, plus 2 minus 0. That's the derivative. So this next question goes much the same way. as both differences and sums. Y is equal to t squared minus 3t plus 1. Then dy dt is equal to d dt of t squared minus d dt of 3t plus d dt of 1. So the first term is just a straight up power rule. Take the power in front, 2t to the 2 minus 1, which is 1, minus, this is the constant multiple rule, 3 times d dt of t to the 1, plus the constant rule. d dt of 1 is d dt of a constant, which is 0. So to simplify this, 2t to the first power is 2t, minus 3 times the derivative of t to the 1. Remember, this is a power rule. You take the 1 in front, it becomes 1t to the 1 minus 1, which is the 0th power. The power of anything, and anything to the 0th power is 1. So this all becomes 1. We have 2t minus 3 plus 0. That's our derivative, 2t minus 3. Here we have g of x, another sum rule. Here we go. dg dx would be equal to the derivative of both terms individually added up. So this is 2 power rules. You know how to do it by now. 2x plus, this is a constant multiple rule and the power rule. So we would have 4 times v dx of x cubed. So now you know how to do this power rule. 2x plus 4 times, bring the power in front, 3x to the old power minus 1, which is 2. So you get 2x plus 12x squared is our final answer. This one is very similar. dy dx is equal to d dx of 4x minus d dx of 3x cubed. These are both constant multiple and power rules. 4 times d dx of 4x to the first power, of x to the first power, and then minus 3 times d dx of x cubed. So now do the power rules. 4 times you bring the coefficient in front, times x to the 0 is 1, so it's 4, minus 3 times, bring the coefficient in front, 3x to the 3 minus 1, which is 2. So we get 4 minus 9, because 3 times 3 is 9, x squared.